Hey everybody, we're going to work on solving systems of equations using substitution. So just a quick reminder that there are several different types of solutions. So if your two functions don't actually intersect, like two parallel lines for instance, then there's going to be no solution, okay? Or if they intersect, if you have two lines, or you'll have one solution, okay? And then if you have two things that are exactly the same, then there's an infinite number of solutions, so all the points on the line. So specifically for substitution, the first thing you need to do is pick an equation and solve for one of the variables, okay? So it doesn't matter if you solve for x or if you solve for y, or maybe you have other variables, but whichever variable is easiest. Then you're going to substitute the expression from step 1 for that variable into the other equation and solve for the variable. Okay, then substitute the value from step 2 into the first equation or the other equation and solve for that, for the other variable. Then write your answer as an ordered pair, or we might have a triple pair, meaning 3 variables, in alphabetical order. So let's jump in and take a look at an example. So our first one is 2x plus y equals -1 and x equals 2y minus 13, okay? So we're going to use substitution to solve for x and y as an ordered pair, right? So x is isolated, so that makes it pretty easy because since x is equal to 2y minus 13, we can take this expression and plug it in for x in the other equation. All right, so when we do that, it says, in this equation, it says 2 times x. Well, x has become 2y minus 13 because that's what x is equal to in the second equation. And then we plug that in for x, then we continue our equation. Plus y equals -1. Now we have one variable and one equation and we can solve. So we're going to distribute, combine like terms, so we get 5y minus 26 equals -1. Add 26 to both sides, so that 5y is equal to a positive 25. Divide both sides by 5, and y is equal to 5. Okay, but y is not our solution. Our solution is an ordered pair with x and y. It has to include both of them. So we use that 5 is equal to y, and we go back and we plug that in for x, because if x is equal to 2 times y, then it's equal to 2 times 5 minus 13. So that is 10 minus 13, and x equals -3. So my ordered pair solution for number 1 is -3, 5. All right. So, and by the way, that was 2 lines, right? This is linear because it's an x to the first power, and then this equation was also linear. So let's take a look at one that is not linear. So in this case, we have y equals x squared minus 3x plus 10. That's a quadratic, which means there's going to be 2 solutions for x, and then y is also equal to 2x plus 16. So what we're going to do here is, again, y is equal to, it's isolated to this 2x plus 16, so we're going to replace y with that x, okay? And so our equation now becomes y becomes 2x plus 16 equals x squared minus 3x plus 10. Okay, and now we're going to go ahead and we're going to solve this. So we're going to set it, because it is a quadratic equation, right? It's got an x squared. We're going to set it equal to 0. So we'll subtract 2x. We get 16 equals x squared minus 5x plus 10. And we're going to subtract 16. And we get 0 equals x squared minus 5x minus 6. So now we are multiplying two numbers that add multiply to -6, add to -5, so we should get -6 and 1. And this factors to x minus 6 times x plus 1. Now remember, we are looking for solutions, so we need to solve for x. So we're going to use the zero product property and set each of our factors equal to 0. So x minus 6 equals 0, or x plus 1 equals 0, and we're going to solve each one. So first we add 6 to both sides, x equals 6, or we subtract 1 from each side, and x equals -1. Okay, so we've got x equals 6 or x equals -1, but that's not our solution to our system. Remember that this is, okay, some kind of parabola with a line intersecting it. So there's a solution here and there's a solution here. So there's an x and a y here, and there's an x and a y here. So we have to take each of these x's and plug them in and solve for y. Okay, so I would say the bottom equation is easier to plug in for y than the top equation. So we're going to say, let's plug in 6 first. So y equals 2 times 6 plus 16, and that's 12 plus 16, and that adds up to 28. So that's the ordered pair. We plugged in 6, and we got out 28. So that's the ordered pair 6, 28. That's one of our ordered pairs. Okay, and then our second ordered pair, let's plug in -1. So we've got y equals, sorry, I'm out of space, 2 times -1 plus 16. So y equals -2 plus 16, and y equals a positive 14. So the other ordered pair was when we plugged in -1 for x, we had an output of 14. So our second ordered pair is -1, 14. Okay. So that one's a little bit more complicated because you have to think about what's happening. You have a quadratic with a line, and so there could be 2 possible solutions, right? And so that's where we get these 2 possible numbers. So we substitute in, we solve the quadratic by setting an equal 0, factor in this case, and then plug each of our x's in to solve for 2 different y's and pair them up. Okay, I want you to take a look at, well, you can pause the video if you want, and then pick up, because I'm going to go ahead and go through number 3 and 4. It'll be kind of quick, so I'd like you to do it before. So pause the video and do it before you watch this, and then check your work, okay? So in number 3, y is isolated. It's already isolated, okay? That is the best case for substitution. So we're going to take what y is equal to, and we're going to plug it in, and we're going to replace y with 1/2 x plus 4. So we start with our equation, x plus 2 times, and then our substitution is -1/2 x plus 4 equals 8. Okay, and so we're going to clean this up, simplify everything. So we get x minus x plus 8 equals 8. And what happens here is x minus x is 0, so we get 8 equals 8. Yeah, that sure is true, and we call that an identity. And an identity is when you have 2 lines that are exactly the same, so you have infinite solutions. Okay, when you get something equal to itself, it's called an identity, and there are infinite solutions. Okay, if you got something like 8 is equal to 6, that means that there are no solutions. Okay, all right, let's take a look at this one. Again, we have a quadratic this time with a line. But what's really nice about this one is y is just equal to -3. So we're going to plug a -3 in for, for y, not for x. Sorry. So we're going to plug in a -3 equals x squared plus 4. Okay? And then we're going to, let's see here, we'll go ahead and subtract our 4 here. And we get negative 7 is equal to x squared. And if we're solving for x, then we're going to take the square root. And we see that x is equal to plus or minus, oh, that's a negative, I root 7. All right, so what's happening here? This is a quadratic, right? Where it's shifted up 4, and so its solutions are imaginary, right? They don't actually cross the x-intercept or the x-axis for x-intercepts, but the solutions are imaginary. And then this is a horizontal line down here at y is equal to negative 3, okay? So do we have any real solutions here? No, they're never going to intersect, so we're never going to have any real solutions for number 4. Okay. All right, over to the back. We'll do 5 and 6, and then we will stop. Okay, things get interesting with 5 and 6. If you take a look at 5 and 6, you see that we have an x, we have a y, and we have a z. And that actually can happen. When that happens, it happens in 3 dimensions. So there is a 3-dimensional plane. So, all right, so in this case, x is equal to 0, and negative 2x is equal to negative 8. And I think that that's a typo. So this has to be like y. We're going to change this to y. And we'll see what happens. Okay. All right, so if x is equal to 0 and negative 2y is equal to negative 8, the first thing is we can actually go ahead and solve this, right? We can divide both sides here and see that y is equal to a positive 4. So if x is equal to 0 and y is equal to 4, then we can pretty easily solve for z. So z is equal to the opposite of x, so negative 0 minus 5 times y was equal to 4 minus a positive 12. And if we simplify that, z equals 0 minus 20 minus 12, which is negative 32. And then if you go back to the instructions asked us to write this as an ordered pair or a triplet in alphabetical order. So we do x first, which was 0, comma y, which was 4, comma z, which was negative 32. Okay, so there is that. Okay, so in this one, we have the same thing. So go ahead and pause and try it. See if you can figure out x. That's pretty easy because it's given. And y, and then work through to solve for z. So pause now and then get the video started again to see my work. So for this one, x is equal to 6, and y is equal to 3 times x plus some number, well, it's just 19, right? So that's pretty easy. We can determine what y is from the get-go. Negative 3 times x, which is 6, plus 19. Well, negative 3 times 6 is negative 18. Plus 19 is a positive 1. So we have x, we have y, and now we need to solve for z. Okay, so we're going to plug our numbers in for x and for y, and then we'll be able to solve for z. So it's negative 6 times, well, x is 6, plus y, which is 1, plus 4z is equal to negative 19. Okay, so negative 36 plus 1 plus 4z equals negative 19. Negative 36 plus 1 is negative 35. Plus 4z is equal to negative 19. So we're going to add 35 to both sides. And 4z is equal to, 35 minus 19 is like 35 minus 20 is 15, minus 1 more is 16. Then we're going to divide by 4 on both sides. And z is equal to 4. So our triplet pair is x is equal to 6, y is equal to 1, and z is equal to 4. 6, 1, and 4. Okay, we're going to stop there, and I will make a second video looking at the 2 word problems that we have.